Welcome to the Ira A. Fulton Schools of Engineering at Arizona State University. Our college houses the undergraduate and graduate degree programs for engineering, computer science, and a majority of the technology programs that are offered at ASU. This presentation will explore the Materials Science and Engineering degree program. ASU has 4 campuses that span the Phoenix metro area, and the Fulton Schools of Engineering are located on 2 of those, the Tempe campus and the Polytechnic campus. The degree programs within the School for Engineering of Matter, Transport, and Energy, also known as SEMTE, are located at the Tempe campus, but all campuses are open to all students regardless of where their program is located. We offer a free inter-campus shuttle for our students so that they can explore courses, student orgs, activities, and resources at any campus. At Fulton, we offer 25 undergraduate degree programs, which provides a lot of choice and flexibility in finding the program that fits for you. We are called the Fulton Schools of Engineering because we categorize our degree programs into 6 schools, which are organized by theme and location. The first 5 schools from left to right are housed at the Tempe campus, and the Polytechnic School is housed at the Polytechnic campus. Our materials students belong to the School for Engineering of Matter, Transport, and Energy, which you will see towards the right of the infographic. Each school has its own director, affiliated faculty, and advising unit so as to provide greater support and specific guidance to the students within that school. ASU and Fulton have direct admission, meaning when a student applies, they apply directly to the degree program they want to pursue. As long as a student meets the admissions criteria for their program of interest, they are admitted. It is important to note that some of our degree programs, including Materials Science and Engineering, have slightly higher admissions criteria than the general university requirements. For a comprehensive list of admissions criteria, you can visit the Fulton Schools of Engineering website at engineering.asu.edu. Students in SEMTE are located at the Tempe campus, which is both their academic and residential home. First-year freshmen are expected to live on campus their first year, and our SEMTE students are currently registering for housing in the Tooker House. Tooker House is the residential hall for all of the engineering disciplines, and we're also expanding to the University House for the 2020-2021 academic year. Students that are part of Barrett the Honors College live in Barrett housing, but are given the opportunity to live on an engineering-specific floor if they choose.
Materials sciences and engineering students develop and design advanced materials for a wide variety of engineering applications. The program prepares students for exciting careers related to design and improvement of the structure, properties, and performance of materials. Our graduates will solve real-world materials engineering challenges within their organization by applying the required technical knowledge and skills. Our graduates will have made demonstrable progress towards their graduate degree or be considered for a technical promotion, potentially within 3 to 5 years of graduation. Our graduates will demonstrate professionalism, leadership, lifelong learning, and ability to work in teams, and will hold positions of increasing responsibility within their organization. Also, our graduates will demonstrate an ethical approach to the profession, including consideration of economic, societal, and environmental impact. The Materials Science and Engineering program consists of 120 credit hours. The multidisciplinary general education classes required in the major complement the specialized courses of the major by teaching fundamental skills. A well-rounded education gives students the tools to think creatively, adapt quickly, and work effectively with others, which are skills needed in any field. The first year in Materials Sciences and Engineering consists of English composition, math, chemistry, and physics. Material Sciences and Engineering specific classes begin in the second semester. Certain courses starting in the second year are only offered once a year. Thus, it is important to stay on track and take each course in the appropriate semester. An accelerated program is available for students pursuing Material Sciences and Engineering, also known as 4+1. Combining graduate and undergraduate coursework in the accelerated program saves students time and money. The research is rigorous and the work is focused, but students get enriched educational experience that will prepare them for doctoral studies or industrial position by earning a BSc and MS in 5 years. Requirements include 3.5 GPA in all courses towards a degree, have earned or in the process of earning 90 credit hours. Up to 9 credits can be shared between the undergraduate and the graduate program. Materials engineers are in demand in a wide variety of industries and professions, including aerospace, automotive, computer, electronics, energy, healthcare, microelectronics, nanotechnology, robotics, and telecommunications. The career path in these industries offer opportunities to impact technological advances through working in a team environment with engineers from chemical, electrical, mechanical, aerospace, and other engineering disciplines.
Hello, my name is Ruth Oliver, and currently I am a junior in the Materials Science and Engineering department here at Arizona State University. Today, I wanted to take a little bit of time to talk about some of the reasons why I joined the materials program specifically, what I like about the program, my favorite classes so far, the things I've been able to do, and the fields and directions I've thought about going in. I hope that all of this information makes your decision of a university and of a program of which to study more easy, as I am super passionate about not only the materials program, but also being a student within the Ira A. Fulton Schools of Engineering here at ASU. The reason why I decided to study materials engineering is because I had a passion for chemistry and math in high school. I always wanted to understand where materials came from, and how one would decide to make a new material, and how to optimize current materials and processes for different applications. For this reason, I was convinced that the materials engineering program was the right program for me. As a member of the program, some of my favorite things about being a materials student here at Arizona State University is the tight community that I have. I am connected with all of my classmates and spend time with them outside of class, studying, doing homework, and having fun on the weekends. I also have been able to get very close with my professors due to the fact that we have small class sizes, and they have given me invaluable advice not only in the classroom, but also for my future, whether I choose to go into industry or academia. My favorite classes so far have been the labs we've been doing our junior year. In one of these labs, we made our own MOSFET and were able to use the different materials characterization techniques that we learned about to understand and analyze this important piece of electrical equipment. I also enjoyed my Intro to Materials Synthesis class that I took my sophomore year, where I got a broad overview of different materials, where they came from, and what their properties are. So far, as a student in the materials program, I've been involved in research, not only here at Arizona State University, but I was also a researcher at a university in Germany. There, I used two-dimensional materials, which are atomically thin materials, to make flexible LEDs, or light-emitting diodes. I have also been involved with the materials department in the Material Advantage Club, which is our club for materials students at ASU. Through this club, I've been able to connect with members of industry and also professors from other universities who have helped give me advice and teach me about the different things in materials that I can be passionate about. I've thought about many different fields within materials. I think that I will be going into my PhD program after I finish my undergraduate. But if I was to go into industry, I believe that I would either work in the semiconductor industry, with nanotechnology or device fabrication, as that is similar to what my research was in Germany, or going into being a systems and processing engineer, as I enjoy learning how to optimize different processes. In all these different ways, materials was the right choice for me. I hope that hearing my story has helped you understand yourself a little bit better and figure out whether or not materials engineering is the right major for you. I love materials engineering, and I'm so happy that I'm in such a versatile program that I can use to benefit myself in so many different ways. I hope that even if you don't choose materials engineering, that you take a serious look at the Ira A. Fulton Schools of Engineering, as I have been equipped with so many resources throughout my years here to truly be a successful student. Thank you for your time today.
Thank you for taking this time to explore the Ira A. Fulton Schools of Engineering. If you have any questions about applying to Fulton, please contact us at fultonschools@asu.edu. If you have any specific questions about the degree program covered in this presentation, please contact us at sempty@asu.edu.